Today we're going to talk about the law of cosines. This is on page 442. It's section 5.6. This is in complement to the law of sines. If you remember, the law of sines was it could only be used when you had a matching pair, either side and an angle, like angle A and side length A, or angle B and side length B. If I didn't have that matching set, then the law of sines wasn't really a possible choice. Now, we didn't really do those because we were studying the law of sines last chapter. Here, sometimes you're given all three sides, or sometimes you're given like side, angle, and side. And if I start with that, I can't actually find the other parts. And so what we're going to do now is we're going to try to figure out how do we take care of all the other types of triangles. So you can see on the screen the three versions of the law of cosines. It's really the same formula, but what about equal to A, equal to B, and equal to C? So you can see it here. It looks a lot like the Pythagorean theorem, and it's definitely related to that. You can use any of these at any point in time. Depends on what you're looking to find. If I want to find angle A or side length A or angle B or side length B, whichever one of those the formula it occurs in, you can do it that way. I would encourage you to really pay attention to how this works out. So you've got A, B, C. So it shows up B, A, C. So this is all occurring just at one point. Right? So they're all three squared and they're not repeated in the first part. The second part of it is going to be minus 2 times something. Well, those two letters that occur after 2 are the two letters that you have here and here. The letter that you have at the end matches the letter that you have at the beginning. All right, make sure that you learn that formula. Don't try to memorize all three of them as if they were all three separate ideas. It's the same formula that occurs in three different varieties. All right, next part would be when can I use it? And so here's some examples of when we can use the law of sines, or law of cosines. One of the first things is what happens when you have all three sides? I don't have any angles at all. So with the law of sines, that's not a possible choice because every formula for law of sines, it was A over sine A equals B over sine B. If I don't have two angles, or at least one angle, the law of sines isn't a possible choice. So when you have this, it's the law of cosines. So this would end up being side, side, side. The next example would be side, angle, side, where you have, here we have a side length, and then the angle, and then a side length. So if I were to write this out, that's B, and then that's angle A, and that's side C. So we have an A, a B, and a C. Just like over here, we had A, then we had B, and we had C. One of each letter is represented. A quick and easy way to remember how to use law of cosines is if you get that A, B, and C, it doesn't matter whether it's angles or sides, you're going to end up using this formula. Let's look at an example. In this case, you're given angle C, which is 20 degrees, side A, which is 11, and side B is 5. And if you haven't figured this out yet, one of the most beneficial things you can do when you're given triangles like this and you're asking to solve them is to actually draw the triangle. And realize that your triangle does not have to actually be drawn to scale. I typically draw the same triangle just about every time that I make a triangle. And so if I put this on paper, or glass in this case, this is what it looks like. You have, I pretty much just went ABC on the triangles, and I knew that C was a small angle because it was 20 degrees, so I just simply made that, when I picked the letters, I just made C not be the top angle at A. And I put the sides in place. Remember, the side, lowercase letters are always sides, uppercase letters are always your angle measurements. I can clearly see that I have side, angle, side, and therefore, because I have also here, I can look up at the top. You've got A, you've got B, and you've got C ready to go, like one of each letter. So that is typical law of cosines material right there. So we're going to go ahead. When I'm ready to try to find my first missing part, I hope that you've gotten into the habit of looking at your formulas and deciding on which ones are going to be useful. I picked the one, since we had angle C here, then this is a clue to which side length we're going to have to find first. In the law of cosines, if you're given an angle, then when you find your first item, it has to be the side length opposite the angle you're given. So that's why I went to the formulas and I picked the one that had c squared on the edge, and that's what it says. If I go directly in and I just plug in all my numbers, I'm going to plug it in right into the formula. Whenever you have side angle side, in my book, in my opinion, this is probably the easiest of the situations, because you're literally going to plug it all in and make sure you're careful. And you could type this all in your calculator in one go and get what c squared is. So that's what it looks like. I'm going to plug it in: 11 squared plus 5 squared minus 2 times 11 times 5 times the cosine of 20. Be very careful about this formula. There's a lot of parts to it, so a lot of potential easy mistakes is to do order of operations incorrectly. You add or subtract when you should have been multiplying or dividing. Next step, I went ahead and I literally typed into my calculator. Now I'm using an 84, so if you have an older calculator that you can't actually type like elements into, you can't see what you're typing, then this might not work so much. But I typed in 11 squared plus 5 squared minus 2 times 11 times 5. Literally, it looked like what I wrote on the screen here. And I'm going to hit enter, and it gives me 42.6338, and it keeps going. Now be careful, that's not C. The very last thing we have to do to find a side length is take the square root of both sides, and once I do that, I have the side length, which makes more sense. I knew that it wasn't going to be incredibly long, because it wasn't going to be longer than 11, because A is the largest angle, C is not, so it had to be less than 11. All right, the next step would be, since I've got all three sides, I'm going to have to find an angle. And I really have the choice. I could find angle A, or I could find angle B. It won't matter, and we'll use the sum of all angles in a triangle is 180 to get the last one. So I'm going to have to use the law of cosines one more time, and this is what we would do. Now, here's a little tip. This is kind of a new version of law of cosines, well, new to you. If you would like, and I encourage you to, I would write that down. Whenever you go to write an angle measurement or find an angle, it's a lot easier to start with the problem that's already equal to cosine of A. And in fact, I can plug my information in and then do inverse cosine of that decimal, and then I have my angle measurement. So, and here again, I'm only going to write one version down. If you wanted to switch it out with cosine of B or cosine of C, it all works out to be the same kind of transformation. Just change the letters accordingly. So when you plug it in, it looks like this. You get all this information up top. Be careful, this is a fraction and it's got lots of squared parts to it, so you could, if you're trying to type this all in at once, I would recommend not doing it that way, but be careful when you're typing all of that into a calculator. I did mine in a couple of steps, so I didn't make a mistake. So go ahead, you find out that decimal, and it turns out to be cosine of A equals negative 0.8269. And I find the inverse cos, and that gives me 145.8. Now, if you were doing this in a calculator that you've kept a lot more decimals than me, then you may have gotten something maybe a little bit closer to 144.8. Depends on how many decimal places you kept up with. And so, because I'd written on the screen 6.5, then I'm just keeping it at 6.5, and so I think there's a little bit of round-off error here. To find angle B, I'm going to go ahead and do like we've always done. You get two angles, add them together, subtract it from 180, and that is your remaining angle of 14.2 degrees. And we're pretty much done. We found angle A, we got B, we've got C, we found side length C, and so we have all 6 elements of my triangle. All right, we're going to do the next example. This is one where you're given all 3 sides. All right, so let's draw the triangle. Here we have ABC side lengths. We have A at 9, B at 7, C at 5. Draw my triangle. I'll label the sides. And before I even knew what the triangle looked like or even thought about it, I have an A, a B, and a C. So that already tells me that I'm going to be using the law of cosines for this problem. I need an angle measurement. So if you remember from the previous example where I showed you you had a way to write the law of cosines for an angle. Here it is again. If you didn't write it down last time, you should write it down this time. It's cosine A equals B squared plus C squared minus A squared over 2BC. If you think about how to learn this particular formula, if you look over here, you've got A, B, and C squared all on the top, right? But one of them is being subtracted. The way that you remember that is whatever the cosine angle is, you're going to be subtracting that same letter, but it's a side length on the top. So since it's cosine A, it's going to be B squared plus C squared minus the A squared. If this had been cosine of, if this were cosine of B, then it's going to be cosine of, or it'll be A squared plus C squared minus B squared. Whatever letter is over here, you're going to subtract it from there. And on the bottom, whatever two letters you're adding to on top, those two same letters occur again. And we're going to write this again just so you can see what it looks like for the other letters. But here we go. I'm going to plug in my information. Just work it out. I plug all that in. Be careful with my calculator. And it turns out I get negative 0.1. If you do inverse cosine, because we have cosine A equals negative 0.1, if I do that inverse cosine, I end up getting 95.7 as angle A. All right, so I guess if you get where it's side, 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 which is what we're in now, you really only have to do law of cosines to find the two different angles and use the 180, the sum of all angles equals 180 to get the third one. So let's go ahead and write out the second one. We're going to write out the formula for cosine of B in terms of what you have here. Hopefully you can see the pattern as we write it out. Like I told you earlier, if you had cosine of B here, then you're going to be subtracting B squared from the other side. So here you have it happen in this case. You see at the bottom you have A and C that are being added together, and we're going to plug our information in and work it out. So here's what it looks like when you plug it in. You notice we got cosine of B equals 0.6333 and it repeats. So if you do the inverse cosine of that decimal, we're going to get our value of B equals 50.7 degrees. And that's pretty much it. We got one more little short step, finding C, which we just add together, subtract from 180, and find out that C is equal to 33.6. And then to complete the results, we found all three angles, which it's easier to find that third angle than it is to find the third side. So when you have all three side lengths, it tends to be a little bit quicker of a problem because you really only have to find two difficult parts, or using the law of cosines. A question that I get a lot of times is, once you find the first side, can I use the law of sines? Yes, you can, with caution. Sometimes you may inadvertently put yourself into the ambiguous case and not realize that you've done that. Depends on how the problem's set up, and it's not a big deal, but just when you finish, I want you to make sure, if you switch between the law of cosines and then the law of sines, I want to make sure that if you add up all your angle measurements, they have to add up to 180. If they don't, you know that you it's not very common, but it can happen where you add them up and you've got more or less than 180. If that's the case, then you obviously have done something wrong. And it's likely, if you didn't make a careless mistake, it's likely that when you switched from the law of cosines into the law of sines, you put yourself into the ambiguous case without knowing it, and you basically didn't have a second triangle, but you tried to make it happen. Anyway, just add them up, make sure that they add to 180. If they add to 180, you're good. All right, and lastly, just to round out the lesson, here's your classwork for today. I've left a law of cosines worksheet that I want you to work on for the remainder of the class. So you still have a fair amount of time that you could get a lot of this done, and some of you may be able to even finish it. So if you finish this, there's no homework, but I want you to take the time. I want you to practice using the law of cosines. Very straightforward. It's a lot more direct than the law of sines is, because there's no such thing as the ambiguous case. So it's just, it works or it doesn't. And so Take the time today and practice this. Make sure that you're comfortable with it using both forms, one for the angle equal, the cosine of A equals, or the ones where you have it's the side length equals, like C squared equals. Make sure you know both of those. Make sure you're comfortable using them with the worksheet I've left for you. We'll go over this tomorrow, but the worksheet will be due tomorrow at the beginning of class, not at the end. You will not get to work on the worksheet in class tomorrow. It's going to be due tomorrow. Okay? So pay attention. Make sure you're working until the end of the bell. Don't sit around and do other things. You need to be working on this all period.